To chat with spacecraft that are hundreds of millions, billions of kilometres away. All the antennas on site are transmitter receivers, sending those commands out there so they know where to go, what to do, don't crash into that, what information to collect and send them back home every single day. We process all that, get it off to a lot of anxious scientists around the world. The antenna uses two simple drive mechanisms for its motion. Elevation gear, the big curved gears you can see under the dish there, 4 bull gear drive motors, each with a 1 in 244,000 gearing ratio. Very accurate elevation movement. We can go from a complete upright position on the dish to right over on its side, so the leading edge is just 90 centimetres off the ground. That move takes 3.5 minutes. Pretty amazing for something that's the equivalent of an 18-storey building moving structure. To be able to move so incredibly gracefully, and it never creaks or groans. It's incredibly well looked after by the teams that work here. Rotation for the antennas on its base. That base goes down about another 2 stories underground. Sitting on top of that base, which is kept horizontal to a tolerance of a 50,000th of a millimetre, is a steel runner. Runs the entire circumference is about 1.5 metres wide. Sitting on top of that, attached to the upper structure, are 3 8-ton blocks of steel. We call them pads. The pads have lots of holes drilled through them. Attached to those holes, lots of pumping systems. Pumping incredibly highly refined oil down through those holes at high pressure. So as the oil comes down through those holes underneath the block, it creates a pressure wave, lifting the entire 4,000 tons, floating on a film of oil only 0.17 of a millimetre thick, about the thickness of a sheet of paper. For all intents and purposes, it's like a hovercraft. They're using oil pressure rather than air pressure to float that 4,000 tons so we can easily rotate it. The antenna can do a 410-degree rotation on the base. That complete rotation takes just over 8 minutes. So between elevation and rotation, we can turn and point anywhere in the solar system with incredible accuracy. Being down in this valley, we're shielded from line-of-sight radio noise coming from the local region. It's one of the reasons why you don't have a mobile phone signal down here. Of course, you need to have the phones off because they're trying to transmit to find a network. So we need to be in a radio quiet spot, pick up these little tiny whispers from incredibly far away. Now, the 70-metre antenna was only designed originally with a 15-year lifetime in mind. That was back when we started operating it in 1972. Well, it's been going for the last 39 years, comes up to its 40th very soon. We'll be celebrating that during the centenary of the ACT in 2013. This dish will probably continue to operate probably into the mid-2020s. They're talking about upgrades to possibly take it even to the 2030s. It will eventually be replaced. Multiple 34-metre antennas will be used in an array, combining them together to simulate the capacity of that big 70-metre, but it takes 5 34-metre antennas to actually do that. This antenna still has the best sensitivity of any of the antennas in the network. It has the only high-power transmitter capable of communicating to the Voyager spacecraft. We have exclusive view of Voyager 2. It's so far south of that of the solar system, not visible in the northern hemisphere. Voyager 1 still up over our northern horizon here. We're the only ones capable of sending commands to it. So those little spacecraft have been sort of our life here. The big 70-metre, its very first mission actually was Apollo 17. The director here wanted to make sure it was online so we could get that last Apollo mission to the moon. Of course, out the front here, our 26-metre antenna, which originally started its life at the Honeysuckle Creek station here in Canberra, about 25 kilometres southwest of here, is the dish that brought back those very first images of Neil Armstrong and Buzz Aldrin walking on the moon. As I delighted saying with Rob Hollow before, not the dish at Parks, as they show in the movie. It's a movie, not a documentary. Parks came in later in the broadcast, of course. At the time when Neil came in the ladder, the moon wasn't high enough above their local horizon. They were unable to lock on and get a clean signal. Honeysuckle had a picture, great picture, that was the right way up, importantly, because California could see that same signal coming back from the moon, but the picture they sent to Houston was upside down. You know, imagine everybody at Houston looking at their screens going, "No! What are we going to do?" You know, Australia came to the rescue. Our dish is here. That dish out the front, probably one of the most famous dishes anywhere in the world. It's retired now after 44 years of service to the space industry. It stays here now as an ongoing monument to all those great missions and to the thousands of men and women who made those missions possible. Let's head up into the operations building. Let's get dry again. Stuff is horrible. And